Okay, microphone is now working. Am I live again? I think I'm live. Say something, Tim. Hello? Hello from Virginia, says Tom. Yay, sound is good. Yeah, so the problem was this thing right here. This is Apple computer, in their infinite wisdom, decided to make everything USB 3 connector. And so everything else in the world is regular USB. And my monitor is HDMI, and the Mac computer doesn't even have an HDMI port. So I have to use this thing to connect to my monitor. And I think this one went belly up, but fortunately I had a spare. Oh man, I am frustrated about the, it was working until I moved a wire, and then it stopped working. Okay, so this is RockSim Live. Thank you everybody for showing up. There's a lot of people here. We have Tom here, Boxcar Jimmy, Vlatno, I don't know how to say your name. He's clapping. We have Carlos K, Pause for Thought, Fat Bank, Rosa. Awesome. That's everybody that's checked in so far. If you haven't checked in, just say hello, where you're watching from. I am Tim Van Million. I think I am. I am having a little bit of a hard time today. Okay, my camera is not showing up. Let's fix that. That was the external microphone. Testing 1, 2, external camera. Okay, our Applewhite is here. Wow, we got some famous people coming in. How come? I'm missing my screen, my desktop screen. I got that main screen, but not my normal face here. That one is not showing up. Main camera. Let's try this. There we go. I'm there. We have Steve from Bishop, California. Right now I am painting my rockets that I just bought from you guys. Yay! We have Ken Llewellyn from Wyoming. Boy, we got a lot of people in the house today. I think my door just opened. I'm in the studio here, and it's a closed room, and somebody is now closing the door. They could have came in. It would have been okay. If you have a RockSim question, go ahead and type it in. I'm looking at the monitor, and now everything is working, so now I can start answering questions. There's so many new people here. I feel like, I don't know. It just feels so nice to have so many new people that I haven't seen here before. This is the Apogee website. So I usually start out these things, just kind of give it a bit of an introduction. RockSim is what we're talking about. If you click on this banner right here, it will take you to how to upgrade from version 9. If you want to learn how to use it, you can go here to how-to and guides on the website, and then come down here to software, and then come over here to RockSim video tutorials. That's a good place to start. We're doing RockSim live training right now, and if you want to see the back episodes, click on that, and this is where you would come, and this lists all the previous episodes that we had. This was episode 60 last week. We talked about mass objects and mass override. That's always a big discussion. There's just like so much confusion. That seems to be like the #1 question people have that know how to use the software. And now they're trying to make sure everything lines up and is accurate, and so they're using mass override, and that's a really good question. And we talked about that last week. Still, oh man, we've got Vlatko is from Bosnia and Herzegovina. Wow, we got another international audience. This is the first time we've ever had anybody from Bosnia and Herzegovina. That's awesome. Thank you for coming. Yeah, I'm waiting for questions. Anybody got one? Nobody's got a question. I got things popping up everywhere here. It's been a busy day here at Apogee. I've had meetings all day. Let me quit this so things don't pop up on me. See, like these things up here, I don't need those things popping up. Let's turn off the favorites bar. Yeah, okay. So, okay, not a RockSim question. Where should pressure relief holes be drilled on a HBR rocket? Okay, so let's bring up a rocket so I can kind of show you here. Oops, wrong button. This is RockSim. This is what we're using today. And to open a design, go up here to the file folder. You can go to your design folder, which is in the application. So in your applications, scroll down to RockSim. Oops, I don't have it sorted by name. So RockSim, I am using RockSim 10.3 F22, no, this one. 3.1.1, I think, is the latest one. In that folder, you'll find a folder called Designs, and then inside Designs are all the different manufacturers. We can choose a North Coast, so they do big rockets. So we can go with the Bounty Hunter. So let's open the Bounty Hunter. Click Open. And it shows a picture here of the Bounty Hunter. And I'm using my scroll wheel to zoom in and out. And if you click and drag, you can rotate the rocket to take a look at it. So this is a high power rocket. And the question is, where would a pressure relief hole go? Well, one is, let me show the design components. They say here's the motor tube. Okay, so by clicking on the motor tube, it kind of highlights it here and kind of ghosts everything else. And that's what I wanted to show. I wanted to show where the centering rings were inside. And in this rocket, we have a centering ring here that's disconnected from the motor tube. Normally, this tube would come all the way up here to that centering ring. So I would definitely not drill it behind this centering ring because it needs to go in the compartment where you expect a extra pressure to occur. So maybe the question that I haven't asked is, why would you use a pressure relief hole? And the reason is your rocket is a pressure vessel. It contains pressure in it. You know, once you put that nose cone on, so here's a rocket, and if we put the nose cone on, we've got pressure inside of it, air pressure, and the rocket engine on the other end is capping it off here. So we have pressure inside, and the pressure, when you close it up, is obviously ground pressure, because it's the pressure on the ground. But as you rocket goes up into the air, the atmospheric pressure decreases. And this is holding pressure, and it's the ground pressure. And then up here at altitude, we have atmospheric pressure is lower. And so you have a pressure difference. And so that pressure difference is, you know, this air inside wants to come out. And usually the easiest way out is, you know, when the nose cone comes off, you release that pressure. But we don't want to release the pressure on the way up with the nose cone, because that's kind of what happened to me a couple weeks ago, where I had an ejection charge go off as the rocket was going up. And then as the rocket was going up, the nose cone came off. The nose cone flipped over. The rocket kept going because it was still stable, and it zippered the side of my tube. That's why we don't want the nose cone coming off as the rocket's going up. So the pressure relief hole is just a small hole in the side of the rocket to vent that pressure from inside so that it doesn't push the nose off. So where would I put it? Well, obviously, like, as I was saying, I would definitely put it in front of that forward bulkhead, and then below the base that's going to be pressurized by the ejection charge. So on this particular rocket, we've got a payload tube up here. We would probably want a pressure relief hole here, and then maybe one over here. And then it doesn't matter where it is in that tube. So I could go anywhere in that tube. Obviously, I don't want to put it where the shoulder is because then it's blocked off. I would probably try to hide it because, you know, you're seeing a hole, and you don't really want to see the hole if you're taking pictures of your rocket going up. And then this rocket here has a launch lug. So what I like to do is put the hole in line with the launch lug, because then when it's sitting on the rod, you can take pictures from any angle, and then the launch rod or the launch rail is hiding the hole. So you could put it next to a rail button, a rail guide, or a launch lug. How big should the hole be? I use about an 1/8 inch hole. It seems to work okay. The air pressure is going to come out, and it's going to equalize pretty good. So hopefully that answers your question about pressure release holes. CS Saravan says, "Sir, I'm from India. I wanted to know if it is possible to throttle control rocket motor." And the answer to that question is, I just saw a video by BPS Space, and he was answering this very question: is can you throttle control a solid rocket motor? And the answer is no, but maybe. And let me see if I can find that video. It's a YouTube video. YouTube. Let's say BPS Space. I gotta spell it right. Space throttle a motor. Yep, right here. Can you throttle? Let me turn that off.
Is better than one.
We're seeing ads. Skip ads. So this is the video that talks about it, and the conclusion is you can throttle it if you put in the nozzle. Let's see if I can find a picture of it here. Yes, think of this stupid ad. This picture right here, what he has is like little clamshells that pinch off the thrust, and then so basically the thrust is no longer going linear out the back. It has to break up and then goes out to the sides, and you can kind of pinch it off, so you can let a little bit go through, or a lot, or none. And if you do that, this was a great video, and this just came out a couple days ago, March 15, 2022. So yeah, go watch that video. BPS Space throttle a motor. That's how you would find it. All right. Go back to the Apogee website. Carlos K says, "Is it easy to drill a circle hole? Are circles good? Fancy race cars don't use round holes." I have never heard that fancy race cars don't use round holes. Is it easy to drill a circle hole? Give me an idea what a circle, where you're using your circle hole. I'm not sure if I totally understand that question. So CS Raven says, "Yes, sir, it was so complex." I think he's talking about that video, but that's, unless you're using a liquid motor or a hybrid motor where you have a valve that you can open and close with precision, yeah, you really can't throttle a solid rocket motor, because once you start them, It's always going to burn. And what controls the burn is the geometry inside the motor. And once the geometry is fixed, you can't change it. So the geometry is like, if you ever looked at a slug of propellant, you know, it's a slug, it's a cylinder. And as a cylinder, so you got a round on the outside, and then on the inside, you can either, this is where the geometry comes in, you can either have a circular hole right through the middle, and that's called a core burner, because you're burning from the core towards the outside, towards the edge, so it burns inside out. And then you can have different patterns, so you can take that circle core and you can move it off to a side, and now it's called a moon burner because it burns out away from that side until it reaches the other side of the cylinder. Those are the easy ones. There's a slot burner. Instead of having a circular hole, it's like a channel, like a square channel. That one you could do. There's star patterns, you know, like in professional rocketry they use star patterns. But once that geometry is fixed, because it's molded into the propellant, and you can't change it. No more questions. Okay, so Fat Bank asks, should the weight of glue or epoxy and paint be accounted for in RockSim? In my opinion, the weight is not significant. Well, it depends on the rocket and how much balsa filler you use. It could be. So what I do is like I'll build a rocket and I'll look at the mass. So like this one says a mass of 500.052 grams. And then I'll take that rocket and weigh it. So in real life, so maybe it weighs 506 grams. You know, you added 6 grams of paint. I don't know. You know, we talked about this last week is, you know, people want to put in that exact amount because the closer you are to actual weight, you know, the more accurate your simulations are going to be, or, you know, we try to be. So they want to account for all the weight. So if I was to account for paint, what I would do is I would look at that rocket. And so if it was 506 grams, so I need to add 6 grams. So where do I add 6 grams? And so then I would take the rocket and balance it. And I would put the weight so that after I add the weight, it balances in that right spot. So let's say on this rocket right here, instead of, you know, this center of gravity here is at 33.89 inches, and we paint it, and now the center of gravity is at 38.6. Okay, so I would add a mass object. A mass object is anything that, it could be anything, could be paint, could be glue, anything. And then I have to, where am I going to put it? Well, I could put it anywhere. Since the center of gravity, if I said 33.6, and this is 33.8, that means it moved the center of gravity forward. So I need to put the mass somewhere forward. And I could choose any component that's forward of the current location. So I wouldn't choose the motor tube because the motor tube is aft. So if I put another mass here, it's going to take this and move it this way, which is in the wrong direction. So I need to be in front of that. So maybe I could put it into that body tube or into the nose cone. Doesn't matter. So let's say I'll put it in the nose cone and I'll just say mass object. I'm going to cancel out of the database. And so right now it's at the very tip. And so it has no mass yet. So if I make this 6 grams, 6.0 grams, hit tab, and it didn't move at all. Oh, it says mass override is on. Oh. Okay. So I need to add more mass. Maybe, I don't know. But you get the point. You know, you'd add the mass and then adjust the location. Oh, there it goes. It did move that time. So 6 grams. It went from 33.8 to now we're through 33.49. So I need to move it back. I'm sliding it back until I get to 33.6. So you can see I'm looking at this number right here. Here's my mass object. That's the paint. Right there. All right, and then what I'd do, I would call this paint and glue. And click OK. So now my mass is right, and I've accounted for the paint. The location is correct. So that's how I would add paint and adhesives or anything else like that. CF's Raven is still trying to control a rocket motor. I'm trying to design a miniature missile thing. So I'm thinking of various ideas to control it. But controlling is such a speed is very difficult. I'm not that strong in theory and stuff. Can you please tell me where I should start? I did tell you where to start. Start with BPS Space. He's the one that's working on that problem. It is a difficult problem, but if you're looking for a simple solution, I'm sorry, this is rocket science. You know, you're going to have to get strong in control theory and electronics, because the only way to control it is, you know, like he's showing, is to use a controller on it, use pinching it off. I like that idea. It was really clever. Yeah. Okay, no other questions yet. Okay. Playtime. What am I working on today? I am working on RockSim.com. This is the launch visualizer. If you haven't been playing with the launch visualizer yet, last week when we were doing this, I learned something brand new, and that was on dual deployment, that it may not always be necessary to use dual deployment. It's going to depend on the rocket. And in the newsletter last week that we sent out, I gave a link to the simulation that we ran here at RockSim Live, and it was pretty interesting. But I didn't tell you one of the secret things was it's going to depend, whether or not you need dual deployment is going to depend on how stable the rocket is. Because if the rocket is overstable, you may not need dual deployment, because the rocket's going to weathercock into the wind. And the further it weathercocks into the wind, then it's going to drift back to you. Let's see if I got a long rocket here. Apogee Diamondback. That's a good rocket. Okay, so it's going to load the Apogee Diamondback, and here's what it looks like. And let's pick a launch site. Oh, I'm not logged in. Crud. Okay, so now I'm logged in. It's loading the maps. So we choose a launch site. Let's see, who are we going to pick on this week? I'm just scrolling through and clicking on something, and Tripoli, Tulsa. Okay, so let's look at their launch area here. It looks like it's in a brown field. Let's look at it from straight up. Yeah, it's the middle of a field, all right. Oh, that's a nice field. We got a stream over here to the east. We got lots of, looks like they're growing grass and maybe some other crops right here. We've got this semicircle. That means that there's a sprinkler system somewhere in here. Let's see if we can find it. There it is right there. There's the sprinkler. So we can't launch right there because that's at the hub of the sprinkler, but we can launch right here. And which direction do we want to launch in? I don't want to go towards the river. So I'm going to aim Let's aim to the west or the southwest. Okay, so to do that, we'll go here to starting state, and we're going to aim it. And we said we're going to go to the west or the southwest, somewhere over here. As I was moving this around, you saw the rocket move on the pad, and you can adjust this and see which direction you're going. Make sure you're going in this direction. I've got a wind right here coming out of the west, so that's fine. Select the rocket motor. If you have a question, go ahead and ask. I'm still taking RockSim questions. I'm just playing right now. I'm kind of showing on dual deployment. Rocket motor, we have this. Let's choose an engine here. And it's probably also going to depend on your high thrust versus low thrust. So let's start with an Estes. Let's make it a Quest, a C12. That's pretty high thrust, and use a long delay. But we're going to use deploy at Apogee, so click OK there, and then go to flight events, and let's say deploy at Apogee. Here, deploy at Apogee. So now when this rocket takes off, it's going to go up, and instead of deploying at 8 seconds, it's going to deploy wherever Apogee is. We don't know where that is right now, but it doesn't matter. And let's launch it. It's going to use 10 credits, and then simulate. Okay, so there's my rocket sitting on the pad, and let's look at it in 2D from above. And it's aimed this way off to the bottom left corner, and that's towards the southeast because north is pointing straight up. I'm zooming out. This still shows the rocket on the pad, which is right there. And okay, so we're going to be launching. Not a lot to see in this nice brown grass, or nice, not grass, brown dirt. Let's angle the rocket. Okay, and then let's launch it. I'm going to turn it into trajectory view, and it rotated around. And then let's launch. It's going to be in the air 43 seconds. So there's the smoke coming out of the rocket, and the blue smoke is tracking smoke, the white smoke is thrust smoke. And the rocket did angle up. We're not seeing the ground track, so let's turn that on. So I'm going to pause it, and then come up here to settings. And then under settings, I'll turn on remember camera view so it remembers what I'm doing. Turn on the trajectory path, and let's do extruded flight path. So that will tell us, you know, where it is in the air, and we're seeing a ground track. And let's turn on the weather tracking cone. And click OK. Okay, so there is the rocket. And so the rocket is right there where my point is. This is the last of the smoke that's still dissipating. You can see the trajectory. It did go to the southwest. And I can look at it from straight down. Okay. All right, so then let's continue launching it, and it's coming down now under parachute. How do I know it's under parachute? Because we got a nice diagonal line. Let me pause. Find the rocket in the sky. So when you click on this button over here, it finds the rocket in the sky, and it's going to center it right dead middle of the screen. So you can always find it. There it goes. And then what you do is you click on these buttons right here, and you can zoom in on it. And yes, you can see it's under parachute. So that's good. Let's zoom out again and see where it's going to land. And my guess is it's going to land somewhere over here in this field. Yep, it crossed the little dirt track. And probably right about there. And we can get a distance right up here, see how far away it is from the launch pad. So that's measured and a diagonal from the launch pad. Okay, so I'm going to pause that and drag the slider all the way to the end so we can stop it. And so it's 735 feet. So let's see if we can get this rocket to land a little bit closer to the pad. Okay, so a couple of things that we can do. One, we can change the launch angle, and that would be a good thing to do. Then the other thing is we can select a different delay, which may or may not be a good thing. It depends. How do you know if you've selected the right or wrong delay, which is a good question. And the answer is it depends on your recovery system. Can your recovery system handle being deployed at a high rate of speed? Because if you open your parachute too fast, or the rocket's traveling too fast, it's just going to grab the parachute and shred it. So we don't want that to happen. Just checking to see. No more questions. There's a lot of people. You got to have some questions. Give me a question. All right, so let's continue with this while we're waiting for a question. And I'm going to close out the animation. And we can see we have all these columns up here, and we can change these columns by clicking on Configure Columns. And you know what I don't see is distance. Hey, I don't have a distance one. That would have been really nice to have. I'll have to add that to my memory. That's what I wanted to show, was distance. Do I have velocity at deployment? Velocity at deployment right here. So I am showing that. So cancel that. So velocity at deployment here, I'm in miles per hour. Let's change that to, that should have been, let's change it back to feet per second. No, let's just leave it at miles per hour. So this last one, on the C-12-8, velocity at deployment was 73 miles per hour. To me, that's kind of fast. I like to keep that. My rule of thumb is under 50 miles per hour. So we're above 50 miles an hour here. And why are we above 50 miles an hour? Is because the rocket has horizontal velocity. So we want to get that number below 50 miles an hour, which means we can't angle it as much as I wanted to. So if I come back here, see right now we're angled at 10.05 degrees. Let's angle it straight up and rerun the simulation and then see how it compares. Simulate. You know what? I'm not looking at the I thought we were using the Diamondback. This is the Avion. I guess when I logged in I forgot to reload my rocket. So, but anyway, that's okay. Let's look at trajectory view. Let's zoom out a little bit. See where this rocket's going to go. This was in the air longer. 45 seconds before we were at 43. Okay, so it did go straighter. Have to rotate it around so we can see which direction it went. Okay, so this time, since we launched straight up, if you look at the ground track, west is this way. So what happened is as it launched, you can see that green line. So the wind, as soon as it came off the launch pad, if the wind was blowing this way, it came off the pad, the wind pushed it this way, and then it arced into the wind. So it went this way and then arced into the wind. And that's why, you can see it started going that way, straight west into the wind. And then, I forgot, I didn't see how far it landed from the pad. Okay, so this one is definitely further from the pad. We're at 901 feet, 922 feet from the pad. So that was definitely further away. Let's see what our velocity at deployment is. So let's close that. So here's the newest simulation. Okay, velocity at deployment is 16 miles per hour. See, my units changed on me because this was 72. That must have been like feet per second. My units are messed up. I got a bug in here. I got to get the programmers working on that. Change it to meters per second, see what happens. Didn't change at all. Still says miles per hour. I have no idea what my units are because it's everything. It keeps displaying velocity in miles per hour. Yeah, it's not changing. But my velocity is a lot lower, which is good. I can live with that. So now, as long as I keep this number under 50, and assuming as we are in miles per hour, I think I'd be okay. So how do I get this? How do I get the rocket closer to the pad? I can arc it further into the wind, and if I arc it further into the wind, this velocity at deployment number is going to climb. But as long as I keep it under 50, that's my rule of thumb. Your parachute may be stronger. If it can open at a higher velocity, that's even better. So let's change the launch angle, which is this button right here. But let's go straight west. So I'm going to change this number here to 270. So now launching straight west. And I can launch at any angle as you know that's NAR legal. So anything under 30 degrees from vertical. So the worst case situation would be 29.99. So let's launch it there and see what the velocity is, see how high it increased. Let's launch it again. No more questions. Okay, so there's the rocket on the pad. Let's put north up to the top. Yeah, we're really arced over. Let's launch it. Wow, this rocket's going really far. Normally I'd like to see that apogee point right here inside the cone. This is the weathercocking cone. That tells us if the rocket is weathercocking too much. This is definitely weathercocking too much because we're way outside the cone. But we're going to be a lot closer to the pad. Look at that. We're going to be like really close. I'm going to pause it right when it gets to the end. Oop, it wasn't quick enough. Look at that. 7 feet away from the pad. That's pretty good. I could live with that if I could, you know. But let's look at the velocity at deployment. Yeah, so now our velocity at deployment is way too high. So somewhere in between straight up and arced at 29.99 degrees, we'll have a velocity that's, you know, what's the greatest angle we could have and still keep that velocity under 50 miles an hour. So then it's just a matter of just running simulations. So let's try 20 degrees and launch. Let's see if we're still, if we're over or under 50 miles per hour at deployment. There's the rocket sitting on the pad. I'm just zooming out. Okay, launching it. Okay, rocket's arcing over. There's Apogee. It looked like it popped right at Apogee. And okay, so now we got to walk a little bit. We're at 291 feet. You can see it. And let's close this and then see our velocity at deployment. 54. Okay, so what did we launch at? We launched at 20 degrees, so we're still arced over too much. So let's do, I'm sure 15 degrees is going to be plenty. So that's the only thing I'm changing. I'm just arcing it. Instead of launching at an angle of 20 degrees, we're going 15 degrees from vertical. And I'm just going to slide the slider bar over to here. You can't see the rocket. Let's go. It's way over here. That's where it landed. Now we have a walking distance of 446 feet, so we are bringing it closer. And then our velocity at deployment, 45.94 degrees. So it's now between, what do we say? 15 degrees and 20 degrees. So if we make it 17 degrees, run it again, simulate, rotate this around, oops, or north is straight up. Okay, we got a question that came in. Okay, so let me just see this last one here. (383 feet, so it's closer to the pad. There's the apogee point. And let's close out of this. 49.54. That's like pretty close. So around 17 degrees is the furthest we can angle this rocket over using that particular rocket engine, this C12-8. Interesting. Robert Benway says, my TARC students are trying to capture the real mass of the rockets by using mass override for every component. How do they correctly use mass override, specifically the CG? This question keeps coming up again and again. Okay, so let's close this out. No, I'll just leave it open. I'll just hide it. Okay, so here's a rocket. And he says, my TARC students are using mass override for every component. How do they correctly use mass override? Okay, so there's several ways. There's 3 ways. We talked about this. You could try to match the component weight using the specifications of the component. So what does that mean? So if I had a nose cone and I clicked edit, I would adjust the wall thickness and the material to match the mass of the rocket. So right now I can see it says the mass override is on. So let me go to mass override, turn that off, and it says the calculated mass of that nose cone is 206.5 grams. If I make the wall thickness thinner, instead of like 0.1/8 of an inch, made it like 0.1/10 of an inch, and hit tab, see the mass dropped because we made the wall thickness thinner. So RockSim is using the shape, the geometry, and it's multiplying the volume. It figures out the volume of that component and multiplies it by a density. And where does it get the density? It gets the density from that material right here. And that's how it gets this weight. So you could do that. That's one way. Another way is to use the mass override for the component. And this is the component. And when you click on this button right here, it will say use that mass. So now it's, instead of using the calculated mass of 167 grams, it's actually using 148 for this part. When you use this, you have to also put in the center of gravity of the part, and that part is measured from the front of that part. So on a nose cone, it says the center of gravity is 6 inches from the tip of the nose cone. If it was a body tube, it would be 6 inches from the front of the body tube. So here's the body tube. So you remember to add both a mass and a center of gravity for each component. And to find the center of gravity, you just balance it on your finger. So I'm just balancing the nose cone. Well, I got this shock cord, but you get the idea. You balance it. So that's the next way. And you do that for every component in the rocket. And it takes a long time, but it's the most accurate way of doing it. Either of those two methods. Using the first method of adjusting the materials and the shape is probably the most accurate, but it takes a lot longer. Using the mass override will get close enough. So you could do that, but you got to do that for every component in the rocket. And then once you got that, then you're going to get an overall weight of the rocket. And the overall weight is right here. So after you do that, then you could weigh the rocket again. And then, like we started out in this particular episode of RockSim Live, we were talking about the weight of paint and glue and what you do, how do you account for that? And we accounted for that by using a mass object. So we added a mass object right here called paint and glue mass, and we added it into the nose cone so that it moved the center of gravity of the entire rocket to the right spot. And now when you run a simulation, what's going to happen is your simulation should be a little bit more accurate, particularly in the shape of the trajectory, because that's where RockSim is best. But if you want just a quick and dirty answer, what you can do is use mass override here. And I wouldn't use this because this one causes confusion, because people they'll say, okay, let's use the overall mass of the rocket. And so then they use this, and then they enter a mass, let's say 506 grams, and then they put in their center of gravity, 33.6 inches, and you have to put in the distance from the center of gravity, and it's always measured from the tip, and then hit tab, and you can see the center of gravity is going to go from here to somewhere around in here. And then that's good, and then you can run a simulation. But then what happens, what causes confusion, is people now say, oh, I want to add more weight to the rocket. I want to add more mass to the nose cone. And so then they come up here, and then they say, let's put more mass in the nose cone. Or you can go here to that mass object. Let's add another mass. So we're going to add more mass like clay. So I'm going to exit out of the database. I'm going to say, call it the clay mass. And, I'm going to add 60 grams, and that's going to go like right about there. So I'm going to move that right about there, and then click OK. And then they say, well, the mass didn't change. It's still 506 grams. Well, that's because you have a mass override turned on. And whenever you turn this on, it ignores every other mass in the rocket, and it's just using one mass. So if you want to come back later and add more mass, don't use this right here. This is what is causing a lot of people confusion. So now if I uncheck this, remember we started out at 500 grams, then we added, then we specified it as 506. So when I uncheck this, I expect this number to be 560 grams. Right here, 566. So now when you add the mass, it is adding the mass. So hopefully that wasn't too confusing. This is quite the question that comes up every week, seems like. Johan has finally showed up. Johan, you're late. You're tardy. You owe everybody a round of beer. Just kidding. Already have daylight savings time here. Yeah, we moved daylight savings time too last weekend. So nothing should have changed. Robert Benway says that is the distance from the owning part? Question mark. Or the distance from the top of the component. It's the distance from the, if you're using mass override for each individual component, right here, this, okay, mass override. So right now I'm in the nose cone, and I say that the center of gravity is 6 inches from the tip of that part. Not the tip of the rocket, but from the tip of that part. Since this is the nose cone, they're both the same. But if I was in a body tube, it would be different. So if I did that for a body tube, so I opened up this body tube right here, and I hit mass override. Right now it's calculating it at 33.336 inches, and this tube is 10 inches long. So since tubes are symmetrical, I know the center of gravity on that particular tube is going to be half the length of the tube. So it's going to be right at 5 inches. So if I use a mass override and I said it was 50 grams, then I need to move the center of gravity halfway. So it's going to be 5 inches, and then I need to check the little box, and then it increased the mass of that particular part. So, but it's not, this CG location is not from the tip, it's from the front of the part. Where it can get really confusing is when you're working with fins, because now you don't know where the front is. And yeah, I have problems with that one too. We have Yeet Forever, who has retracted 2 messages, and he says it's 5 o'clock in the morning there. Where are you, Yeet? You must be somewhere, in Asia? Johan says it's not 10 p.m. here. Fatbank says, when will model rocket design and construction be available on Kindle? As soon as we run out of the printed version. When we run out of our stock, then I might turn on Kindle, but not until before then. The problem with putting anything into digital form is once it's in digital form, you don't know who has it and who bought it and who didn't, and people can give it away to somebody. Yeah, That's my problem with Kindle, is I like to control distribution. Kindle is not bad because Amazon controls who gets it, but still it's in digital format. You know, once it's in digital format, people always ask for the PDF version. And then that, if I gave out a PDF version, then it's just like, it's everywhere. And then the problem with Kindle is just the images might not look good as it does in printed form. Get the book, you'll be happy. He's in Australia, so I was close. I said somewhere in the Asia region. So welcome, Yeet. I don't think you have been here before, or if you have, I don't remember. Any other questions? We've gone an hour, although we did screw up the first 5 minutes because I was having problems with my HDMI connector for my monitors. It went belly up on me. Okay. Rick DeFossa says, now in the air over Nebraska. Are you on an airplane? Rick was here this weekend. I get to meet Rick. He was so cool. I didn't get to talk to him very long, but I did enjoy our little conversation. He brought a friend with, and he's trying to get his friend into rocketry. Rick says he might be the first one participating from an airplane. Yeah, as far as I know, you are. You're the highest person that we've had here. What are you at, like 29,000, 33,000 feet? Johan says, we had our first launch event this week. A bit chilly still, though. Launched my new egg rocket on 2A10 and a B64. That was harder than it looked. Yeah, that sounds cool. A 3-engine cluster. Did you design it in RockSim? I hope you did. Yeet Forever says, I have a problem when I design my rocket in RockSim and then take it into the launch visualizer. It loads the file but doesn't technically load, so I can't visualize it. Huh. Yeet, maybe send me the file by email and see if I have the same issue that you have. Vlatko says, I would like to contact you regarding the import and sell of your products. That's fine. We can ship everything but rocket motors and igniters. So if you just want rockets, we can send them to you. But if you want the motors, we can't send them to you. And most of the time, people just don't want the rockets by themselves. And I can understand. But if you can get motors there some other way, in Europe you can get motors from Klima. They're out of Germany. If you can get motors from them, our rockets will fly using the Klima motors. So that might be your option. So just use our contact form on our website. So let me open our website. So here's our website, Apogee Rockets, and then just come over here to contact form. Just click on that, and that will get to you. Johan says, I saw the video you posted on your company history. Very nice video. Thank you, Johan. And Vlatko says, I have motors. Okay. Well, then we'll be happy to talk to you, Vlatko. Mob Rocket says, dag nabbit, time changed and messed me up. I'll watch the rebroadcast. Thanks for doing these, Tim. You and your company and team are awesome. Crazy. You just got my NCR Bounty Hunter from you, and we were using the Bounty Hunter as our example today. Johan says, yeah, I run RockSim on the egg rocket. First flight was exciting. One engine did not ignite, and it came thundering down about 5 meters above the earth. It ejected, and the egg bounced on the ground. It bounced. Did it crack though? Yeet says, Tim, have you had an order recently for a 36 printed parachute and a heat shield? That I don't know, Yeet. I don't always see all the orders come in. We got a team here that handles all the good stuff. So it may have come in. Johan says the egg survived. Good. I was on the world, or my daughters were on the World Space Modeling Championship team, and in 2018, and we were flying in Lviv, Ukraine, and which is now in the news because of the war going on there, and the field was spongy soft. Like if you were sitting on the ground and somebody walked by you, you would bounce up and down like this. And we were doing an egg lofting competition and nobody could crack an egg. It was so spongy that we thought there was something wrong with the eggs because nobody could crack an egg. You know, we were taking the eggs and we were throwing them, just raw eggs, just throwing them up in the air. They'd hit the ground and they'd bounce. It was kind of interesting. That was in Lviv, Ukraine. Okay, well, I don't see any more questions, so we'll stop the broadcast. So thanks for watching. You've been watching the Apogee RockSim Live. We do these every Friday, and I think I should be back again. I almost went snow skiing today. Johan said it was a bit cold there in he's in the Netherlands. Here in Colorado, it's still winter. Even though spring starts this weekend, it's still winter here. And we had snow yesterday. We had a nice snow, probably about that much snow. And so my daughter is home for spring break, and she wanted to go skiing. So we're probably going to go skiing this weekend. But I almost went today, but I stuck around for you guys. I already committed to you, so I'm going to be here. So hopefully I'll be here next week. Maybe my leg will be in a cast from skiing. I don't know. I hope not. Johan says, probably peat in the soil. Here also, areas, it is like waves when you drive vehicles on it. That might be really cool to do. Feel the waves. Okay, so thanks for watching. We'll be here next week, 2 p.m. Mountain Time, 4 p.m. on the East Coast. Really early in the morning in Australia, really late at night in Bosnia, Herzegovina. If you can come next week, great. I'd love to see you again. We had a big audience today, so thank you all again for coming. And we'll see you next week. So we're going to launch in 3, 2, 1. Go out and launch something.